direkt record demek istiyorum. Anlaştık mı?
Aha.
Then got it diyerek sağlı solu ilerliyoruz. Baby bu böyle dik mi daha bir hoşuna gidiyor yoksa yampirik yumpirik mi?
Hiç fark etmez.
Okay, then o zaman ilerliyoruz. Then today we are going to dealing with another properties of weak acids and weak bases. As we know, weak acids are partially ionized to produce such kind of hydrogen plus and A minus ions. Since they are partially ionized, let's say 1% of ionization exists for HA weak acid, and with the concentration of 10 to minus 2, then we will end up with what? The 1% of minus 2 will yield as 10 to minus 4 and 10 to minus 4 respectively. Since it's a kind of equilibrium state, we should have a KL value, which is just multiplication of 10 to minus 4 and division of 10 to minus 2, and which will give us 10 to minus 6. And this number stays stable when the temperature kept constant, okay? And then let's say the whole reaction is completed up at room temperature. Okay, then this one is very fundamental property of weak acid. Then we have another property of weak acid, which is buffer solution. The buffer solution is simply that in weak acid equilibrium, we have enough of anion and original acid. Same thing can be told for weak bases, but this one quite easy because to state there as HA, it's quite easy to understand and teach. That's why I prefer using buffers with weak acids. Then let's say again, we have enough number of anion and the original weak acid. This situation will turn into buffer solution. This solution is tend to be buffer. And what is the main purpose of preparing buffer solutions, baby? Why we need to prepare buffer solutions? What's the idea of buffer solution, baby? Because they have what type of pH value? What type of pH value, baby? The buffer solutions have what? A quite stable pH values, baby. Because in buffer solution, let's say we prepare a buffer of 5, it will try to stay as 5 while addition of some acid or some base and even some amount of water. Okay? The meaning, the idea of preparing weak acid buffer is to get a pH value which tends to be stable for addition some amount of acid, base, and water. Okay, baby?
Okay.
That's why we intend to prepare weak acid buffer solutions. Or same thing can be told for weak base buffer solutions also. Then today we are going to deal with another property of weak acid, which is hydrolysis. Baby, what do you think when you heard the word of hydrolysis, baby?
I think about analyzing the reaction with a product of water.
Yeah, the hydrolysis is that you trying to say is dehydration, baby. Dehydration is producing some amount of water, but hydrolysis means reacting with water. You said that, okay, the word hydrolysis is something involve water. Okay, you are right. We are dealing with a reaction with water, but what type of reaction? Such kind of reaction, baby. Let's say we have HA weak acid, and okay, we know that it has a Ka value is something 10 to minus 5. Okay.
Okay.
But the reverse of this reaction is what? The reverse of this reaction is something like that. And what is the Ka prime value for this one? Why prime? Because this is just a reverse reaction. That's why I put prime for the Ka value, baby. What it should be?
10 to 5.
Yeah, because it's 1 over 10 to minus 5. Okay, you are right. This is really, you are right, baby. Then we have a situation. We have a situation that we just have only anion for this weak acid paper. Of course, the aqueous solution of anion contains some amount of water. Okay, we have this one also. Then what we have? We have an anion which is willingly wants to prepare the weak acid with such a big rate constant paper, okay, equilibrium constant. Then that means this H1 really wants to get hydrogen plus and to produce HA weak acid originally. But what we have? Do we have hydrogen plus ions in this situation? The aqueous solution of A minus. Do we have any hydrogen plus ions, maybe?
No.
No, we don't have. But how they can be came from? They can be came from water. Because we know that the water itself has a kind of equilibrium, and we said that as water constant, K water, and which is really a low value, it's something 10 to minus 14. But in that position, our A minus should react with water to produce the original HA and what?
Heat.
Not heat, baby. Of course, yes, it's heat, but it's something more OH minus, something like that. And this one is called as hydrolysis. You are stuck with conjugate base of weak acid, and it will react with water to produce original weak acid, and it will release some amount of OH minus. Okay? But what type of reaction is this? It's a kind of reaction that we are just adding ionization of water with reverse of weak acid paper, which is something HA, just simple addition. What we have, I don't know, but we don't have any H plus for this addition. Then we will end up with water react with A minus to yield original acid and OH minus. You get the idea. The first one is just ionization of water. The second one is reverse of weak acid. And then we have what? Then we have a good calculation to find the hydrolysis equilibrium. Why we have dealing with an equilibrium state, baby? Because this is KH. KH means the equilibrium of hydrolysis. Why? Because we have the normal K water, no? Please try to remember the previous equations, baby. We just have the normal way of K water, but we have reverse of weak acid equilibrium. And this calculation is going to yield us KH value for this hydrolysis of A minus, and which is simply 10 to minus 14 should be divided by 10 to minus 5. The same is the same. The product should be divided by reactants. Okay.
Okay.
And for each hydrolysis equilibrium, we have to calculate this hydrolysis equilibrium constant for each equation, baby, because always we have a unique Ka constant value, while we are dealing with same and constant K water equilibrium constant. Okay. For each time, we have to calculate the K water constant for our hydrolysis reaction. Okay, this is the case. Then let's say we have what? We have a K hydrolysis, then which is 10 to minus 14 should be divided by 10 to minus what? 10 to minus 5, I believe it was 10 to minus 5. Okay, then we have this one. What are they? This one is Ka value, and this one is the normal K water value. Okay?
Okay.
Then let's add some numbers to our phenomena. Okay. Are you still good, baby? Okay, then we will see. Let's say the concentration of A minus to be, let's 10 to minus 1 mole, okay? And what will be the pH of this solution while H minus is hydrolyzed? Okay, then let's see. We have A minus should react with water to produce HA and some amount of OH minus. What we may say from this equation, baby, we just say that any conjugate pair of weak acid is actually act as bases, no? Because they produce OH minus. The same thing can be told for weak bases, baby. The conjugate of weak bases are acids, okay?
Okay.
Okay, then let's see what we have. We have the concentration, and let's make it in blues. We have the concentration of A minus. We have no concentration definition for pure water because it's not possible to get even concentrated version of pure water. Do we have such kind of thing, baby? Is it possible to have better water than water? Is it possible?
No.
It's not. Then let's see what we have. We have freshly prepared OH minus, but we have no idea about its concentration. And also we have freshly prepared HA for a weak acid. And still we have no idea for concentrations of those guys, okay? Then we have what? We have a situation of K hydrolysis, which is 10 to minus 14 should be divided by 10 to minus 5. And also we have X time X must be divided by 10 to minus 1. Then what the hell is going on? Let's check. And this one is something 10 to minus 4 and 10 to minus 10. And it will yield 10 to minus 5 for X accordingly. Okay? This is called one. This is not now, baby. This is show us the concentration of OH minus is something 10 to minus 5, which POH is 5. Is it okay?
Yes.
No, baby, because we are asked for what the heck the pH was, but we just calculate the POH for the solution. Then we should say that, okay,
It's 9.
This one, then we have completed with a great success, okay? Then now the mission accomplished. Okay, baby?
Okay.
This is the case. This is the case for Başak abla. Bana bir çay yapar mısın baby? Boğam nasıl çok acıyor. Üstüne. Aha, şu yapsın, şu Atakan. Okay then, baby, let's make further calculations for hydrolysis. Did you get the idea, baby? Did you get the idea?
Yeah.
Maybe the simplest form is this one. If this one is a weak acid, the the A minus will be what? A minus will be what, baby? What type of ion it is?
Weak base.
Yes, Lavio. Not weak, it's a base.
Okay.
Why base? Because it depends on the hydrolysis value. For this one, what we have, let's try to see. We have 10 to minus 5, then yield 10 to minus 9. Okay, for this one, okay, we have weak base. But sometimes, according to calculations, and with respect to the division of K water value 10 to minus 14, we may face that with strong base situation. Okay.
Okay.
It just depends on how weak our original acid is. If our original acid is really, really weak one, let's say we have 10 to minus 14 should divided by 10 to minus 20, then we will face up with such kind of lovely thing. And for that kind of equation, we will end up with strong base situation. Okay?
Okay.
It just depends on how weak our original guy was. Okay?
Okay.
Then let's say this one is base, and the same thing should be told for weak bases. Do you have any idea what is the weak base is? Any real example can you give me?
We have the sweet water we drink.
Yeah, okay, but I want to see the chemical. The chemical. Which chemical is really famous to be weak base, baby?
Potassium hydroxide is a strong base.
Okay, then this guy is quite strong, maybe the one of the strongest one. Since it has the hydroxide of 1A, it's a strong base. But for the weak base situation, we have such kind of, which is ammonia.
Okay.
Because ammonia is not actually a hydroxide of metal. It's not a hydroxide of metal. It just intend to be base through water. It makes water to produce hydroxide ions while it turns into ammonia. Actually, the reaction of ammonia also a kind of hydrolysis, baby. Okay. Then, thank you. Then we said that if the weak base is ammonia, its conjugate acid is ammonium. This one also should be acid. Okay, baby?
Okay.
I believe you will remember this one from our previous examples. For example, if we have HA and reaction of ammonia, then we will end up with ammonium and A minus. What we can say that this one produce some hydrogen plus, and it should be an acid, and this one just the conjugate of it, and it should be based on. We have just said this one as Grommet-Lower acid theory. Okay? And this one also, we said that this is base, and accordingly, this one should be acid. Same thing. The same theoretical knowledge from Bronsted acid base theory. Now we are doing some calculations around it. Okay, baby?
Okay.
Then we have another candidate to be good, which is ammonium, and it's a kind of acid, baby. Okay? Something hard, baby. Then let's see. Okay, I just want to say that we have a weak acid of HB and with the Ka value of unknown. Then we have the aqueous solution of B minus. The B minus is, let's say, have a concentration of 10 to minus 2 with the pH of 8. Okay?
Okay.
Then I just want we to calculate the Ka value for HB. What we have the hydrolysis of B minus ions to yield original weak acid and what? Additionally, we have to produce what? What, baby?
Carbon dioxide.
Not carbon dioxide, baby, because this one gets one hydrogen from water, then the OH minus should be free.
Yeah, sorry.
Okay, then just to be a little bit more careful, baby.
Okay.
Then we have the hydrolysis situation, which is the 10 to minus 14 should be divided by Ka, while we have what? We have the pH of 8. Then what will be the concentration of OH minus, baby, as we have pH of 8?
10 to minus 8.
No, baby, no.
10 to minus 6.
What? Minus 6, because this is just something related with hydrogen plus ion, but we just want to know something about hydroxide and which should be 10 to minus 6. Okay. Then this one also 10 to minus 6. Do we have any additional information for this equilibrium, baby?
We have the B ion's molarity.
Yeah, which is what?
10 to minus 2.
Then we have what information about water?
It's also 10 to minus 2.
No, because since it's a kind of pure liquid, it has no concentration. It's not defined concentration, because as I told you previously, it's not possible to have better water than water. It's not possible.
Okay, I thought about the coefficients.
No, baby. Then we have no number involved for this calculation, okay? Then we have what? We have what? 10 to minus 6 times 10 to minus 6 should be divided by 10 to minus 2. And we will see what the hell is going on.
10 to
Then
minus-
this one is something 10 to minus 10. No? Am I okay with it?
Yes.
Then more simplification will yield as the KL value for this weak acid is something 10 to minus 4.
Mhm.
Okay, baby?
Okay.
Good, good. Oh, such kind of good dog, baby. Another husky in the neighborhood, baby. Brown bar, okay. But you have no interest for huskies, I believe, no?
Me, I have a husky.
You, just to be kidding me. Do you?
Yeah, I do.
You should send me photos of him or her.
Her.
Her?
Yeah.
Then I will send you both because we have both. We have him and her together.
I'll send you.
Okay then. And what's the name of your husky, baby?
Fadik.
Oh, it's such a girlish name for a husky baby. And then we will see what. Let's check for Ismira's sister. She is suffering. Then same thing for Bashar Abla also. She's suffering too. Then let's see. Let's jump to our Fanabda. Then okay, we have, let's say, such kind of thing with HA and the KA value of this one is something 10 to minus 6. Then we have not HA, I'm sorry, we have sodium A, let's say. And the concentration of this one is something 10 to minus 2. And I just want you to calculate what is the pH value for this weak acid buffer solution. Since I'm such kind of polite teacher, I'm going to write down the equation for this weak acid hydrolysis paper.
Okay.
Then we will end up with HA and OH minus, but rest of is depend on you. Do you have pencil and paper, baby?
I have.
Then okay. And then fight with the question. Okay. I give you some lovely amounts of minutes, baby. Okay, then.
Okay.
Let's give you 5 minutes.
Alright.
And I want answer from you, baby. Okay, let's start.
I found 9.
Yeah, let's check whether the answer is 9 or what. Okay, then let's say we have the concentration of A is something 2. And what's the concentration of water, baby?
None.
Yeah, allow you. This is the null concentration. Then we have what? What's the concentration of original acid which produced after the equilibrium, baby?
We have 10 to minus 8.
No, this is X. This is X.
Yeah.
The initial, it's X. Then we have what? We have the X times X should be divided by 10 to minus 2. And then the other way, we have what? We have K hydrolysis, which is what, baby?
10 to minus 14 divided by 10 to minus 6, which yields 10 to minus 8.
I believe 10 to minus 8 is the right answer, but after that, you will face up with this one, 10 to minus 8 and 10 to minus 2. Then we have what? We have the x squared is something equals to 10 to minus 10. Then we have 10 to minus 5 is what?
Hydroxide.
And this one, the POH is 5, then
So
the
pH is 9.
9. Then you said what? 9?
9.
Love you, baby. Then I believe you done it with a great success. Okay, this is really good, baby. This is really good. Then I want you to tell me, but then now I'm mixed up all phenomena, baby, okay?
Okay.
Just I'm going to shoot you with unordered way of weak acid-base calculations. Then I want you to tell me what will be the POH value for the HA weak acid with a Ka value of 10 to minus 7. Then you will have 4 minutes, baby, okay?
Okay. Is it 6?
You said what, baby? What you are telling me? What, 6? Are you sure you said that the POH is 6? Let me write down it's as 6 and to be recorded. Okay. Then we have what? We have an equilibrium of weak acids. Then it will ionize such and such ions. And we have originally, what's the concentration of HA? Do we have any information about this one?
We have the 10 to minus 1.
Then what about the hydrogen plus ion concentration?
It's going to be 10 to minus.
No, it's going to be X, baby. Yeah, this one also. I just want you to show me your work, baby, calculations.
Okay.
They both X. Then we have what? X will be divided by 10 to minus 1, and those should be equal to 10 to minus 7. Then X squared will be something 10 to minus 8, and X is 10 to minus 4. Okay?
Okay.
Then I believe the POH is nothing like 6-ish, baby, because
It's 10.
we have pH of 4, then we have POH of 10. Your answer is originally wrong because I'm just giving you a weak acid and you said that POH 6, which means the pH of this one is 8 and 8 is in basic region, baby. It's not possible, but let's tell me what's your mistake. What's your mistake, baby?
I think I did the equation wrong. I wrote A minus plus water to HA and hydroxide.
Then you think that this question is something hydrolysis, but no, this is just a simple equilibrium of weak acid, baby.
Okay.
Then this is just because you are just given with a simple weak acid concentration and only Ka value. Then, since you have original acid and Ka value, you have to complete up equilibrium for this one. It's not a hydrolysis reaction. This is just a simple weak acid ionization, okay? And then let me shoot you with the second one. The second one is something like that. We have the Ka value of 10 to minus 7, and we have what? We have the Ha concentration of 10 to minus 2 molar, and additionally, we have some H minus, which is 10 to minus 3 molar as concentration. Then I want you to give me the answer for what the heck the pOH for this solution. Okay, then you have.
This is hydrolysis, right?
No, this is buffer, baby.
Okay.
Why? Because you have both weak acid and some amount of its conjugate base. Okay, that is buffer.
I found it as 8.
You always say either 8 or 9. Then let's check what the pOH of our solution, which is really 8 or what. Let's see. Let's make a simple calculation. As you said, we have pOH of 8. Then you intend to say what pH value for us?
6.
Yeah, this one. Up to now, okay, it's okay. You are right. You claim that our pH value is something 6. Then let's check what the heck has happened, baby. This is H plus and A minus. Then we have 10 to minus 2, no, for this one.
Yeah.
Then do we have any additional information, baby?
A minus we have as 10 to minus 3.
Yeah, exactly. We have. And what's the concentration of hydrogen plus, baby?
So it's 10 to minus 6.
No, it will turn into 10 to minus 6, but now for now, it's a kind of handsome X. What is handsome X, baby?
It just
Handsome X is clean is the table. Clean is handsome X, okay? 10 to minus 3 should be divided by 10 to minus 2, which should yield 10 to minus. Okay, you are right, because we have a real good amount of simplification followed by, and we said that our clean is equals to 10 to minus 6, which is we have pH of 6 and pOH of 8. Okay, okay, then one last shoot, babe. Okay, are you ready?
Yeah.
Okay, then. Let's say we have a minus aqueous solution with 10 to minus 2 molar concentration. And we have the weak acid dissociation constant as 10 to minus 8 for HA. Then I want to ask what the pH value for this solution. Please tell me, what is it? The normal ionization of weak acid, buffer, or hydrolysis?
Normal ionization. I think
What will it?
ionization.
This one hydrolysis, baby. What? Because we just have A minus, no? Then
No, we don't have HA as a starters.
yeah, of course, we just have the value of this one. We just have the Ka value for HA.
Okay.
Okay, then that means you are dealing with the hydrolysis, and which will be HaNOH minus.
Okay.
Then the rest of is depends on you, baby. Okay.
Okay. I think it's 10.
Okay, then let me say that it's 10. We will see. But just for beginning, the 10 may be the right answer. Why? Because the 10 is something in alkaline region. And after the reaction, we should produce some amount of OH, and which concentration is now is hence max. And OH, not OH, the A minus is something 10 to minus 2, and X times X over 10 to minus 2 will be 10 to minus 14 divided by what? It's 8. Okay, let's see. Simplification, this is minus 6, then it will be what? Is it 6, baby? You know, not 6, I believe. What? Okay,
It's 8.
8, baby, 8, baby. No, the x squared is something minus 8. The normal x something, it's something 10 to minus 4. Then we have what? We have the POH is something 10 to minus 4. Then it will be, okay, you are right, baby. Okay, then you are right. Then we have our class is and dismissed. Baby, I will send you some questions for this one, the hydrolysis functions and weak acid and base calculations. And I want them to what? Let's say before our next lesson, maybe, okay?
Okay.
Okay, now you should be really proud of you because you have completed with a great success, okay?
Okay.
Okay, love you, baby. See you soon.
See you. Bye.
Bye-bye.